Hello everybody, Radu here with Infinet Wireless. Thank you very much for joining me. Today's webinar is called InfiMONITOR from Inside, and as the name suggests, it will be all about how the different components of our monitoring system work. As always, we will have a Q&A session in the end, but if you have any questions during the webinar, please write them down in the chat section. My colleague Dmitry Amirov is also online and he can answer some of your questions as well. So I'm going to start by explaining what is InfiMONITOR for those of you who haven't used it yet. InfiMONITOR is an EMS or an element monitoring system which allows you to monitor the health of your Infinet Wireless network. In other words, it represents the network element which is responsible for monitoring, status analysis, and announcement in case of degradation of the wireless network parameters. At Infinet Wireless, we don't just produce wireless access equipment, but we also aim to create a full-fledged ecosystem that provides the most efficient operation conditions for our products. That is why we pay great attention to solving problems related to wireless networks monitoring and centralized management. The monitoring system application will help you to timely respond to changes in the wireless network as well as improve its manageability and scalability. To effectively monitor the wireless network status, the product displays all the Infinet Wireless hosts and links in the network in the form of both lists and a map, where the operator can view the key parameter values like, for example, link load level, host or link current status, the number of errors and retries during data transfer, signal level, CPU load level, and so on. InfiMONITOR is developed by a small team of 13 people in total, and this is not their only project. The same team is responsible for the InfiPlanner radio planning tool, the IW Academy portal, and a few other projects. There are 3 web developers within the team. Their job is to create the InfiMONITOR interface. Now they are working on a new interface which will be available in the near future, and it will be a huge improvement over the current version. We also have 4 system developers which are engaged in the development of the polling, event generation, and historical data recording subsystems. Then there is 1 tester. Her role within the team is extremely important because the decisions whether to release a new version or not are based on her resolutions. Next, we have 3 technical writers and analysts that create the technical requirements and user manuals. Without them, InfiMONITOR could only be understood by advanced engineers. And finally, there are 2 managers that are responsible for the developing of InfiMONITOR. Next, a bit of history. In 2006, we had a first attempt at developing an application for monitoring the status of the Infinet Wireless devices and links. But compared to the company's main products, the application did not have high priority, so it was developed only by 1 person and it was not released. Then, for a few years, nothing new happened in this regard, so by 2012, there was a long-felt need for a monitoring system. Eventually, NMS Cacti was chosen as a basis for the new application. And 2 years later, InfiMONITOR was created as a plugin for NMS Cacti. This system had 2 main disadvantages. First, it was dependent on a third-party NMS, and second, it could only support a limited number of devices. 2015 was a turning point for InfiMONITOR because we decided to give up Cacti and develop an independent product. The first version of the application was released in early 2016 and it was called InfiMONITOR 2016.1. Between 2016 and 2017, our developers, in conjunction with the company's customers, have been adding functionality and eliminating errors from InfiMONITOR. Thanks to these joint efforts, most of the bugs have been eliminated. For the current version, called InfiMONITOR 2018.1.3, the number of incorrect application behavior reports has been much lower compared to the older versions. At the moment, the InfiMONITOR team is busy developing the next InfiMONITOR version with a completely new interface. The release is scheduled for 2019 and the working title is simply InfiMONITOR Next. Moving on, I want to show you how the polling mechanism of InfiMONITOR works. It is depicted in this animation, but first I need to mention that this description corresponds to the current version of InfiMONITOR and the mechanism could change in future versions. So as you can see, the device polling is done during cycles and one cycle lasts for 5 minutes. For each poll device, a time slot is allocated, which depends on the total number of devices that need to be polled. So the bigger the number of devices, the smaller the time slot will be. The polling cycle has several stages, like for example determining if a device is already known or if it's a new one. The polling telemetry depends on the device family, so it is different for R5000 or XG devices. InfiMONITOR also processes notifications sent by the devices via the SNMP trap mechanism, and these notifications can initiate additional device polling or event generation. One of the key features of InfiMONITOR is to build an accurate map of all the links within the network, and a subsystem called link building is responsible for this task. It receives the necessary information about the devices during polling, and then it determines in real time to which known hosts they are connected. The creation of an event will be triggered whenever one or more of the host or link parameters will deviate from the normal values. The event generation rules are stored in the system. There is a set of predefined rules, but the user can also create new ones. When the events are generated, the subsystem sends notifications both via the InfiMONITOR interface and via email. After receiving an event notification, the operator changes the event status to acknowledged. For the other people involved in the network monitoring process, this means that the notification has been seen by a particular operator which has taken the appropriate measures in order to solve the problem. There are 3 ways in which an event can be closed. First, if the operator notices that the problem is no longer present, he can resolve the event manually from the user interface by simply changing the event status to resolved. Then the event can be automatically closed by InfiMONITOR if the closing condition is met. Let's look at an example. Suppose we have a host with the up status, so it is working fine, but at some point, because of an interference, the connection to it was lost. InfiMONITOR first triggers an event signaling that the host is down. But if after some time the interference disappears and the communication is restored, the event will be automatically resolved. This behavior is configurable in the rule editing interface. And the third way in which an event can be closed is when the acknowledgement time expires. This is what the developers call the rotten state. So if an event is not acknowledged within 24 hours, its status will be automatically changed by InfiMONITOR from new to aged. Moving on to the historical data storage subsystem, which collects telemetry from the polling subsystem and stores it for later use, like for creating statistics graphs in the user interface. The subsystem works as follows. During the whole day, all the collected telemetry data is put into one big stack. At the end of the day, a trigger processes this stack and then sections with the size of one day are created. One section represents one table in the database management system. This allows InfiMONITOR to quickly remove old data. Different compression algorithms are used for the different types of telemetry data. The removal time for the old sections can be configured by the user. and in future releases, the old sections will be forcibly deleted if the disk space runs out. Most networks, especially the largest ones, are built using equipment from several vendors. This makes the network monitorization process very challenging. Using several autonomous monitoring systems, one from each manufacturer, is very inconvenient and even impossible when you have devices from a large number of vendors. So, to monitor such systems, an umbrella architecture must be used. It involves deploying a single NMS that interacts with the EMSs, which are vendor dependent, through the northbound interface. This way, the information from all the monitoring systems is aggregated into one place. One of the most recent features of InfiMONITOR is the backup server. There have been many challenges for the developers to create an efficient backup system, mostly because the database system of InfiMONITOR can be very large. It can easily reach hundreds of gigabytes in case of large networks. Obviously, the backup process could not be performed on the InfiMONITOR instance itself. Therefore, we decided to develop a daughter product called InfiMONITOR Backup Server, which handles the backup database. The main goals pursued by our developers were to minimize the system load during backup, to update the backup as often as possible, ideally every minute, to reduce the backup storage maintenance, and to minimize the recovery time from backup. Because the so-called classical database management systems have some major drawbacks like high disk and network load or inefficient data compression, they were considered inadequate for the InfiMONITOR backup. So our developers started looking for other solutions. It's not a secret that the InfiMONITOR is based on the Linux operating system, so first we decided to see what solutions Linux could offer in this regard. And that's how we found out about the LVM, or Logical Volume Manager. The backup process consists of two steps. First, creating the physical copy and then sending it to the backup server. Because LVM enables performing consistent backups by taking snapshots of the logical volume, we could consider using it to create the physical copy. So we could get the instant file system snapshots, which we could process independently without interfering with the rest of the system or the previous snapshots. However, the LVM snapshots have a problem. They require you to specify the amount of disk space required to store the changes between the snapshot and the original data. Obviously, in our case, we can't know how much space we will need in the future for the snapshot. Moreover, if the space allocated for the snapshot runs out, we get input-output errors when writing into the main volume. But nevertheless, the InfiMONITOR developers got hooked on the idea of snapshots and they started looking for similar solutions. And luckily, in their search, they came across BTRFS, which is a modern file system developed by Oracle in the Linux kernel. It supports instant file system snapshots, and as a bonus, compression is done on the fly using a variety of algorithms. It was just what we needed. Now, our developers were faced with the next task of delivering the snapshot with the backup data to the backup server without excessively loading the network. Even though BTRFS supports the instant transfer of its volumes over the network, this approach had the same disadvantages as the classic backup with physical access. Like, for example, in case of lost connection, it is necessary to completely resend the data, creating peaks in the network load graph. So, we took the decision to make a database replica on the backup server and take the snapshots directly on it. Yes, the initial synchronization may take some time and it may consume some network and disk resources, but the subsequent changes will be delivered in small fragments. As a result, for the main InfiMONITOR server, the disk and network load during backups is minimized, and we also have an up-to-date copy over which the backup operation can be performed. The BTRFS snapshots are instant, therefore you can create them as often as you want. The snapshots are performed using the COW or copy on write principle. This means that only the files that have been changed will be copied to the backup server. The files that didn't change will not incur any traffic between the main and the backup servers. The main volume compression is provided on the fly by BTRFS, and during our tests we've noticed that the compression reduces the occupied disk space by 30 to 60%. Since we don't need to create an archive to compress the backup data, restoring the system from the backup server is much easier to perform. So in case the main server fails, the restore process will only require copying files over the network. Initially, InfiMONITOR was designed to serve only around 50 to 100 devices, so when customers wanted to monitor more than 2,000 devices, we were faced with a challenge. The main problematic subsystems in these conditions were the historical data storage and the events modules, but thankfully in the most recent releases of InfiMONITOR, the system is much more stable and it can handle large networks of a few thousand devices without any issues. So our recommendation is to update InfiMONITOR as often as possible to make sure that you always have the latest version. And in the end, I want to give you a short teaser for the upcoming InfiMONITOR platform. As I mentioned earlier, the working title is InfiMONITOR Next, and its release is scheduled for next year. We will focus on delivering high performance under heavy loads, reducing the storage requirements, providing a more user-friendly interface, simplifying the overall network management, and providing quick updates. In the next few slides, I will show you a few screenshots from the new interface. For example, this is how a graph for a CPU load will look like. This is a bitrate and load statistic for a link. In the next slide, you can see how the list of events will look like. And finally, this is a list of InfiMONITOR users. So this brings us to the end of the presentation. Now, if you have any questions, please write them down and I will answer them one by one along with my colleague Dimitri. Thank you. So first question regarding an issue with InfiMONITOR that sometimes it's hanging and it's showing a red line for critical errors with links when the links are actually working fine. I think this is an issue for the support, for our support team. There can be many causes for that problem, so I strongly advise you to contact our support team at support@infinetewireless.com, and they will be more than happy to help you with issues of this kind. Next question, where can we find the software? There are a number of places from which you can download InfiMONITOR, from our FTP server, but also from our website, infinetewireless.com. In the product section you can find InfiMONITOR, and from there you will be able to download it. Okay, next question, how we can upgrade InfiMONITOR. There are a number of ways to do this. InfiMONITOR, if you have the InfiMONITOR instance directly connected to the internet, it will perform the updates automatically, so you don't have to do anything. Just configure the internet connection and then all is done automatically. Or there is a procedure in our manual. I think I can leave you the link in the description. You can upgrade manually as well, so you just download the next version of InfiMONITOR and perform a setup from the settings of InfiMONITOR. Next question, what actions or operations can you do from InfiMONITOR towards the Infinet Wireless devices? As Dimitri also said, the current version is only for monitoring, but in the future version, in InfiMONITOR Next, some management functions will be available. Next question, when it will be released about InfiMONITOR Next? Sometime next year, so 2019 is the schedule for the InfiMONITOR Next release, but I don't think we can tell you exactly the date when it will be released, but I'm sure my colleagues from the InfiMONITOR team are working hard to bring it to you as soon as possible. There was another question about the upgrade of InfiMONITOR. When you perform the upgrade, do you have to change any settings or do some modifications? Usually no. So after doing the upgrade, your all settings will be saved, so you won't have to redo anything. Another question: how can we make a graph for link history in InfiMONITOR? Can you be more specific? What do you mean by link history? You mean when the link has been up and down, or do you mean some parameters for a link? Because the link parameters can be easily plotted into a graph by going to graphs in the InfiMONITOR interface. Yeah, so here you have links, hosts, and for the link you have several parameters that you can plot, like bitrate, load, current level, retries, and so on. Yeah, so as Dimitri said, you can also select the events with the link down type for the period that you are interested in. Okay, so I see that there are no more questions. So thank you all once again, and see you next time.